Okay, picking up where we left off, it's 24 hours. Well, that's 86,400 seconds. Well, we know the mass of the Earth, and we know what G is. Now we have to solve for R. So let's square both sides. Now we can bring this R up to here. That'll give us R cubed. Bring the times squared over to this side and divide by 4 pi squared. Do the math and you get 4.225 times 10 to the 7th meters. But that's the radius of the orbit. What's the height above the Earth? Subtract the radius of the Earth and you get 3.589 times 10 to the 7th meters. That's about 22,300 miles. Considering the Earth's radius is about 8,000 miles, wow, that's way out there. So what's the big deal about all this? There's dozens of these satellites all around the Earth at 22,300 miles up, and they're stationed above places above the equator. It's all done for radio communications. An antenna on Earth aimed at a satellite beams a signal, which can then relay the signal around the Earth. That's the idea behind dish TV. If you have an antenna at your house, it doesn't scan the sky looking for moving satellites. It's aimed at a particular satellite above the equator, and then the dish stays in that orientation. If these satellites were in low Earth orbit, your dish TV would have to keep tracking them. It would be much more difficult to do that. Well, here's another problem. Here's the sun, here's the Earth. The Earth has a force due to gravity pulling it from the sun. There's an orbital velocity, so it doesn't fall into the sun. Using this information, we could find the mass of the sun. If you say the centripetal force is caused by gravity, it's the same setup for any orbit. The little mass now is the mass of the Earth. The big mass is the mass of the sun. It's still the same formula. It's just that that big mass is the mass of the sun. Any idea what that orbital velocity is? Yeah, it's a distance over time. And that's the distance around the orbit divided by the time it takes to go around. Anybody know the distance from the Earth to the sun? It's 93 million miles. That's about 1.5 times 10 to the 11th meters. Now, people ask me, well, is that the distance from the surface of the sun to the surface of the Earth? Do we have to add in the radii? Don't worry about it. That number is so big that the extra distance isn't going to change anything. We'll just go with this number. Then we have to ask you, what is the orbital period? How long does it take the Earth to go around the sun? You better know that one. 1 year. That's about 3 times 10 to the 7th seconds. Well, that's about 29,800 meters per second. Well, if we know the radius, we can now find the mass. Well, we get a mass of the sun of 2 times 10 to the 30th kilograms. A little hard to believe how big that is. How about compared to the mass of the Earth? That's over 300,000 times the mass of the Earth. All right, let's go back to the Earth with the cannon shooting the ball. It's going to go partway around the Earth. I shoot it fast enough and it makes an orbit. Let's zoom up on this. Imagine I'm shooting a gun right above the Earth. The bullet travels sideways. It'll curve down to hit the Earth. What if the Earth curved just as much as the bullet curved? Then the bullet won't hit the Earth. Well, I know that the Earth curves about 8 inches in 1 mile. Let's use that information to find the orbital velocity near the surface of the Earth. We'll just do a projectile motion problem. We'll say the range is equal to Vx times t. How do we get t? From the time it takes to drop 8 inches. Well, that's 0.2032 meters. Since we're on the surface of the Earth, we can use 9.8 meters per second squared. Hey, that gives us a time of 0.2036 seconds. What's the range? It's 1 mile to drop the 8 inches. Well, that's 1,609 meters. We can now calculate the v in the x direction. Hey, that x velocity is the orbital velocity, 7,903 meters per second, calculated using projectile motion. Now, this method only works when you're near the surface of the Earth because we know it curves at 8 inches a mile. So as long as the trajectory curves as much as the surface of the Earth, it'll stay in orbit. It'll never hit the Earth. We can check this with the orbital velocity formula. But since we're near the surface of the Earth, we'll use the radius of the Earth for the orbital radius. Let's see what we get. 7,919. I'd say that checks out. That's just rounding error. Now you might wonder, how do we know the Earth curves 8 inches every mile? Well, we know the radius of the Earth. And if we go 1 mile, we're still at the radius of the Earth. But if we went straight, we would be a certain height above the Earth. We'll put the 1 mile up here, and then we'll see that their height drops by 8 inches in 1 mile of horizontal travel. Use Pythagorean theorem, and you can get 8 inches. Make sure you practice these problems in the worksheets and in the chapter notes.